Welcome back. Welcome back to Module 1 of Programming in C, where we're going to talk about data types. This is our next micro lecture, so let's jump in and make it quick. What are data types? Well, as we spoke about in the last lecture, our data types really allow us to control what type is stored in what storage location. But we didn't really go into what data types are. So I'm going to go to the source. I'm going to go to ISO, because ISO is the committee and the organization which governs changes in the language of C. And let's talk about data types. I'm also going to be using W3 schools. I really do like the way that they present data in a very succinct manner. We're going to use them as well. So first things first, let's talk about the first data type and what data types are. Data types are, for all intents and purposes, the way that the data is stored. What is it stored as? All right. So there are different types of data types. The first one is, well, that's the eraser. Let's try that one again. The first type is a bool. Okay. And what the bool does for us, all right, is it gives us a variable that can store true or false, 1 or 0, on or off. I'm going to say that again. A Boolean data type stores true or false, 1 or 0, on or off. Now, why is that important? Well, at its most, atomic level, your processor uses electrical impulses to derive or to show us the output of the algorithms that it's trying to calculate. And normally what it does is it gives us a on, which means that the electrical impulse on the transistor is on, and an electrical impulse is found, or off, where the electrical impulse is a 0. Now, at its very atomic, at the smallest common denominator level of the processors, that's the way things work. So you would not be remiss if you thought that Boolean was an extremely primitive data type. As a matter of fact, C is one of the first languages that really catapulted us out of assembly language or languages like assembly language in the late 80s, early 90s. C was very important to a lot of the development processes, even before that, to allow us to get our procedural programming underway. And you would be surprised at how many things actually still use C. C is pervasive in automotive, in aviation. C is used prolifically with small form factor devices like Strawberry Pie or even like your little Tamagotchi toy from the store, if they still sell those. Those all may use C because C is extremely light and portable. Now, what is the issue with bool? Well, nothing. But bool can only store true or false. So we need other data types. So the next data type I want to talk about is char. Now, in the last class or the last lecture, we talked about char. But we spoke about char, we discussed char within the context of a string, where char was just a passive notion. Now let's talk about what a char actually is. A char is a symbol. Now, if we Googled ASCII 2, or even if we looked at a Latin library, those libraries contain symbols. Those symbols can be alphabets, they can be numerical, they can be percent sign, dollar sign, and whatnot. They can be a lot of things. But please understand that a character is a symbol that is stored within that storage location. And by default, only one symbol can be stored at one time in one storage location when using a char. Great. Please understand, string is not a primitive type. Char, bool, and int are all, and floating points are all primitive types. We will be going over in great detail. But strings are not. And the reason why strings are not primitive types is because a string is created from another data type. Strings are derived, all right, from characters. Therefore, strings cannot be a primitive type in C, C++, or Java for that matter. Now, going up further, strings are more of a primitive data type in other languages like C# and whatnot, but C++, C, and those languages, there is no primitive type for char. Now, the next thing I want to talk about is the 5 standard signed integer types, right? Now, we have signed char, we have short int, we have long int, we have long int. Now, I'm not going to go over all of these in detail because they're not necessarily ones that are used prolifically, but the one that is used prolifically is int. Now, what's the difference between signed char and signed int? Well, signed chars are symbols, signed ints are numbers, but they're smaller than int. Int is smaller than long int, and long int is I'm sorry, long int is bigger than long int is bigger than int is bigger than short int, and sign char is smaller than short int. Now, what do I mean by smaller? It's smaller in size, literally. The kilobytes required or allowed for each of these data types is categorically different. And because of that, over time, we've had to add new int types to accommodate bigger numbers. Because our equations, our algorithms, and the things that we're trying to calculate have gotten bigger, and the numbers have become much larger over time. Please understand that at its core value, an integer is nothing more than a number without decimal spaces. That's it. If you decided you want to convert from a floating point decimal number to an int, that it will not round it. It will only display that number without the decimal point, which makes that conversion extremely inefficient. The last data type I want to talk about are the floating point data types, and these are the ones that I've seen used a little, almost as much as strings. Now, I said strings are not primitive types, but they're used quite a lot. Floating point is used quite a lot as well. And it's used quite a lot because in certain situations, the output of certain mathematical algorithms or operators can only be floating point. So if I multiply a decimal number, or if I multiply a floating point number with an integer type, I will get a floating point number as an output. But if I tried to save that into an integer variable, I would only get the absolute value, and I wouldn't get the decimal as well. Now, there's different types of floating points, and the reason why we have different types of floating points is because there are different sizes to floating point derived from the actual storage location that you're using. There are certain situations where using the vaunted doubles are huge, right? It might not be necessary if you're not using large numbers, especially if you have a finite amount of space that you're dealing with. If you're on a small device that is handheld and it doesn't have a lot of power or a lot of storage, then it doesn't make a lot of sense to store a lot of things or to have large data types being used within the program to store values, because that can soak up energy and it can soak up space a lot faster than you would like it to. And that's it. The rest of this is par for the course. So W3 Schools kind of goes the same route. We have ints, floats, doubles, and chars. These are our basic data types, as well as Boolean. I feel like they've left Boolean out, unless it's in its own specific. It is. Booleans are its own specific. But Boolean is a data type that is used prolifically within the C space. And as you can see, ints are actually 2 to 4 bytes in size. Floats are 4 bytes in size. Doubles are 8. These get huge after a while. Long is also not represented here, but them's the breaks. These are your format specifiers that you would use in your printf or your string context. Your string interpolation when you want to interpolate things into a string format. Interpolation just means build. The way I would build my string if I had variables and I wanted to use the values in those variables. Great. So we've already talked about int. So let's use the same thing we did last class or last lecture. And let's do some things. I'm going to go back to Boolean because I want to start with Booleans. Does it give me the string interpolation for that? I believe it does. So, cool. We're going to leave this as D, and we're going to say Boolean, bool x, we'll say true, or maybe it's Boolean. Let's just verify. It is bool. I'm wondering why it's crying about that. Bool x equals true. Oh, I guess it's crying about this, x. Possibly. Bool x. What is wrong with bool? Undefined identifier. Go to the error. X. Bool x. I wonder if I'm not allowed to do it. Oh, I have to pull in the library for Boolean. Yep, there it is. Boom. So now I pulled in the library for Boolean. So now Boolean exists as a data type, and now I can run it. And now you'll see down here Hello world, it is 1. Why did it print as 1? It printed as 1 because in C, boolean doesn't print as true. So if I wanted to print the word true, I would have to do an if statement of some kind that said convert it to true if it is 1. And that's the way boolean works. If I wanted, we talked about strings before, so we're not going to go over that again, but a char works the same way. Char, in order to create a char, what I would essentially do is assign it one symbol. In this case, I would assign the letter A. Now, if I wanted to print a char, which in this case, I need to change the actual, I need to change the format specifier here so that it interpolates correctly. There we go. And if I run this, that's just a warning. This should run. It is, it didn't save it. Why? Incompatible pointer to integer conversion. Why are you trying to convert to integer? You shouldn't be. Maybe it's trying to use a sign chart and I don't want it to. I'm wondering if I give it, I'm wondering if I give it the actual numerical location in the library of the character itself, will it give me the character? 8. Okay, so what is 56? Well, glad you asked. So if I go to the ASCII2 library, good old Bing, and I look up 56 on my decimal chart, 56, the symbol for 56 is the number 8. Now the reason why I used the actual decimal number is because I wanted to see if it was going to give back to me the actual symbol that I wanted as a character, and it does. Now what's interesting here is it also, if you look here, it gives me a hexadecimal number. This hexadecimal number is basically a bunch of ones and zeros or ons and offs that describe to us that value. This value 56 is represented in this number. You might be asking, well, how is that possible? Well, each of these digits in this number represent a value. I believe it's 1, 2, 4, 8, 16, 32, 64, 128. All right? 1, 2, 4 plus 8 plus these three numbers here, and I think I counted that wrong, but these three numbers here equal 56. It might be 2, 4, 8, 12. I'm sorry, 8, 16, 32. That sounds about right. 8, 16, 32 sounds like it equals 56, because what I said earlier didn't. And that's the way this hexadecimal number works. That is the way that your processor visualizes numbers, as a series of ones and zeros in an octet. Those octets can be represented by an 8-bit octet, 32-bit octet, or 32 bits of 4 octets. An octet is 8 bits, right? 64 bits, which is, I believe, 8 octets, and 128 bits, which is bigger than 8 octets. I'm not going to keep doing the numbers. But either way, the more processing power that we've gotten over time allows us to process more of these hexadecimal numbers faster because we can process more of them at the same time, or perceptively at the same time. All right, this is a micro lecture, so I want to jump into the last bit that I want to talk about, which is floating point numbers. Now, in this class, don't get hung up about whether or not to use a double or a long or a float. In the end, just use a double. All right. Now, obviously, you can see straight off the bat, this doesn't like it. Well, that's because we need to change this format specifier so it does like it. But I'm wondering, this is an integer, 56, right? It's not a decimal number. I didn't add a decimal. How and why am I allowed to add 56 to this x if x is a floating point data type, double? Well, because it's going to convert it to a decimal when it receives it. And because the conversion works just fine, and it doesn't need to think about it, it says, okay, I'll just add the 0 so you know it's a decimal. In the end that I wanted to add a decimal, I could, and now it has the appropriate decimal numbers that is required. But in the end, a double is just that, a number with decimals. The same thing with long and the same thing with float. You're not going to find a big change between the two. Actually, it's long double. My apologies. Right? And then you also have float. Not going to change the format specifiers because that's pain. But here we go, float. If I just said F and print, it might not print at all. Oh, it did. Perfect. Oh, would you look at that? It also printed the exact number because floats are far more specific than doubles. But we don't use floats a whole lot in C because floats are extremely specific, which means that they're extremely big in size. Doubles are larger when it comes to the amount of decimal digits you can use, but floats are far more precise. Notice here, it didn't say that I put in .35. It says I put in 0.349998, which is interesting. Either way, I'm going to stop here. I'm not going to go any further. Oh, by the way, you can use constants with these as well. As long as you put const in front of them, you can lock the values and they won't change. Well, that's all I wanted to talk about in this lecture. It's already gone over way farther than I wanted to. There's a lot of content to cover. So as I say in all my videos, good luck, have fun, ciao.